Today I'm going to be looking into the power side of a Getty's Mark 6 drive. I've already got to looking a little bit into this pulse transformer that mounts on the board for the trigger for the SCR. I'm actually going to go ahead and pull this assembly out so we can look at all 6 SCR modules. We can get a better look at it. I've already got the cables undone from the other side, from the control side. I loosened up my screws and this whole assembly just slides out. So we don't see too many of these older DC drives around anymore, but they are still running. There's still some in operation. I'm looking into the power side of this one today, and I've already taken the pulse transformer off of this board, and I actually did not desolder it. It was getting a bad connection. As I wiggled the transformer, it actually pulled out. So that's a sure sign that I need to go through and resolder all these connections. Just a vibration the way it's mounted on the machine, and built in probably the early to mid 80s, so it's got a lot of age on it. Still a well-built machine. This came out of a Cincinnati Millicron 20V CNC machine center. So I have the gate and the cathode loose from the board. The transformers are loose, and now we can see the rather large SCR module, the heatsink and SCR together. As we look a little closer, we can see the marking on the SCR. We see the anode at the bottom, so it's pretty typical that the screw-in main base is actually your anode and your cathode and gates at the top. And one thing's for sure, when you work on these older DC drives, these heat sinks where some of the AC comes in and goes out. So 9 times out of 10 on an older drive with the heat sinks are going to be hot. They're going to be AC hot. Keep that in mind. So we see here on the configuration that this cathode is going to this heat sink and this cathode is going to this heat sink. So to check this SCR, I'm going to take my red lead and just hook it to where the anode would be. The black lead to go, I can do it here, or I could do it here. It's the same wire on the cathode. And I should be getting into the mega ohms, and it is. It's like it's got a little capacitance on it, but it is actually up there. 400K range shows maybe a little bit better on the video. So now if we take our gate and go to our cathode, there will be no change. It will still be open. But if we take our gate and we take it to our anode, we see we go to 0 ohms or close to it. We see that our ohm meter does have enough power to actually close the gate. And if we just go back to auto ranging and we just go across our gate and our cathode, we see about 18 ohms. This one will probably show better on these. Do a little better with your leads. We see 2.5 ohms on these. We go across the rest of these, and that's because of the transformer. The transformer is still in the circuit. We have a look at the transformer, we'll see there's our 2.4 ohms. So these I have to take them loose to check them. But we'll be right back. I'll take them all loose and we'll check them all. So now I have the cathode loose on all these. We got right at 20 ohms. Right at 20 ohms. Close to 20 ohms, so they all showing well above that 2 ohms they were reading through the transformer. Now to do the same test on the rest of these. Go to our 400K ohm setting, and we have it across our cathode and our anode, or anode and our cathode. And there we go. Just go on down the line here. There we go. And these are isolated through this fiber board, except for the one that has to bust across here, of course. So there we go, all our SCR modules actually check good. So now I have all 6 of the pulse transformer boards off of the Mark 6 drive. I've cleaned this one up and got it in a holder. This for sure is going to be leaded solder. Just go ahead and give these spots a good cleaning. And right here. Gonna clean it up nice, especially being that leaded solder. Got everything cleaned up. Just to reattach the transformer. It does on well. I think we got lucky, nothing's really wrong with the transformer. Just a bad solder joints. I was able to bend the pins back out and all is well. Get some more leaded solder here to put back on it. Put a little bit of flux to help clean on there. It'll help transfer the heat and clean at the same time. I'm actually going to touch these up while I'm here. Here's actually the terminal connections. Some of these solder joints are a lot more obvious than others. Obvious issues with the solder joints cracked and just separating. Try to get a little close-up video so you can see it better. We'll try to get it under the microscope. I'm actually going to put some rosin core flux on these. You have to clean it up a little more, but it just does a better job. This one here really isn't doing anything. It's just actually holding the transformer. It's helping hold it in place, but that's still important. So that's got all the boards resoldered. I just got to clean them up. We can put them back on the power modules. It's amazing how much just new rosin core solder and actually using the rosin flux as well, how to help clean and shine up the terminals. Gives you that like a brand new solder joint there. All 6 pulse cards in good condition. We'll put them back on the power modules, and this is actually a plug-in to the drive that actually sends your gate pulse from the control modules. Just going through and doing a final check. Good. Good. Just checking them. I'll just go through and check them all before. And of course, going across these 100 ohm 10 watt resistors and going across these caps for the snubber circuit for the SCR, just to make sure that they're good before we install it into the drive. Now we just put the SCR modules back in place. We'll feed this through and connect it up on the other side. So that's got the SCR modules back in place. I just have to plug them in on this side. Still some more work to do with the the field controller board. This board controls the field and the field weakening. I got 2 cards out of it. I got a couple cards out here as well going through them. That's usually what I do, is take the individual cards out and look at them. Check some of the components, check the connections, clean them up. As well as check especially this drive that was having issues with the power block. The SCR is firing on the oscilloscope, just didn't look right on the power block on this drive running. So with this being a 20 horsepower drive, after I get some of my basic checks done, the next step will be to load test it, which I can't do here. Yeah, like I say, it's a 20 horsepower DC, pretty big motor. So I will have to stick it in a machine to test it. For me, I don't have a testing rig for it. But it's a quick video about checking the SCRs and what goes into a vintage drive. It's a 1980s drive. You don't see as many of them around anymore, but still need to check them out and get them back going sometimes. And they really are a workhorse. They're strong. They can handle a lot of current. And back in the day, they did the job when AC couldn't. So I have started phasing these drives out. I'll try to show a picture up above where I have done a retrofit with a digital DC drive to take its place. I'll try to also have a picture of this complete drive in place before the change out, a before and after shot, because I don't have all the boards in this one at the time of this video. But it's still a need to fix these old drives and keep them going, but I am slowly getting away from them. And the drive pictured above is a pretty neat digital DC drive where it actually will do the field weakening for the 4,000 RPM motor that's needed for the 20V CNC machine. A lot of spindles on the CNC machines are similar, where the field weakening goes down really low in amps on the field to overspeed the motor. I know the 10V and the 20V both have a 4,000 RPM motor. They both had this drive. One had a different resistor here for the horsepower. Both drives are actually 20 horsepower, but one had a 10 horsepower resistor. And of course the 20 horsepower having a resistor for the 20 horsepower. So that's the difference. So I also replaced them with a 20 horsepower drive. That way, with the same drive, either motor. So if you like this video looking into the SCR models and testing, please like, share, and subscribe. Thanks for watching.